now we'll be talking more about the sequences and a few more features of the sequences. These all are the things which we're going to discuss in this section. Before that, we're going to discuss few questions, right? Just say somebody asks you that what is the nth term of the sequence? Say sequence is 1, root 2, 3, right? Right? Let me put it in another way. 1, root 2, root 9, okay? So root 3, root 4, and so on. So what is the nth term of this sequence? And the term is what? Yeah,
Root 10.
Root 10. This is A1, this is A2, this is A3, and so on. So we know that the general rule is this. So the sequence can be described as an is equal to square root of n, right? And there are few more examples. These are pretty much simple. We don't expect it to, that you see these kinds of question in your exam. But these are just the starting questions. Okay. So one is produce the sequence. We will use the first 4 terms of the sequence, and that sequence is what? A1 is given to be 1 and an is given to be n times the an minus 1 for all n greater than equal to 2. Now see, you have A1, right? That is 1. You want to find out A2. What is your A2? You put n is equal to 2 and here 2 minus 1. So that becomes 2 times the A1. That means 2 times the 1, which is 2. You want to A3, 3 times the A3 minus 1, 3 times the A2, 3 times 2, which is equal to 6. Right? Please switch off your mic. See, if I need to switch off your mic, then I probably will remove you. Okay. Now see. So see, we want to calculate A4. So what is the rule? 4 times A3. And we have already determined the A3, that is what? 6, 24. So can you tell me, so what kind of sequence it is? C1 and 2 and then 6 and then 24.
24.
Yeah. Can you tell me what is the general term of this sequence?
So n factor.
N
Multiply by a n minus 1.
Factorial n. That's it. Check करो जरा. हो पा रहा?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Okay.
Yes, sir.
So there may be something tricky questions like 1, 0, 1, 0, 1, 0. How to write this? Can you tell me what is the general term?
Yes, sir. So
You may write it as 1 if n is odd, 0 if n is even. Or you may write it as an is equal to 1 plus minus 1 raised to power n plus 1 by 2. Will this work?
Yes, sir. Yes, sir.
Yeah, this is a kind of switch over there. One time plus, minus, plus, minus. So it will keep on fluctuating between 0, 1, 0, 1, 0, 1, and so on. So are you with me on this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So let's start with some other example. That is what? Very informally. I'm not doing it in a proper mathematical way. Let's start with a very informal definition of subsequence. What is subsequence? So it is subsequence. terms of sequence appear in another sequence in the given order, in their order, right? Something like what? Now, serious. If you have a sequence 1, 2, 3, 4, 5, so on, of course, your an is n. So, can I extract two subsequence? That is, another is, say, I call it as bn, 2n, ncn, 2n plus 1. Now, if you see, the terms of bn would be what? 2, है ना? क्या आ जाएंगे?
Yes, sir.
2,
Yes, sir.
4, 6,
6,
8,
8,
and so on.
10.
Yes, sir.
And what about Cn?
3,
3, 5,
5,
7,
7, 9.
7.
7, 9,
right?
11.
Now you see that. So here are the terms over here: 2, 4, 6, and so on. So order नहीं break किया गया. We didn't change the order, and you see that this is your subsequence bn's, right, and cn's. This is your cn and this is your bn. Is it okay?
Yes,
Now,
sir.
Yes, sir.
why?
Yes,
So,
sir.
so we clearly say that 2n and 2n plus 1 are the subsequences of n, right?
Yes.
And there may be some other subsequence as well. Let me write it as 4n. That is also a subsequence of n, right?
Yes,
Like 4, 8. So we didn't change the order. Order is as it is, but we are picking few terms from the sequence, right? 4, 8, and 12, and so on. Is it okay?
Yes, sir.
Is it okay?
Yes, sir.
So why subsequence is so much important, right? So I'll tell you why. Okay. So there are few notes. If a sequence an is convergent to L, then every, right, mark my word, every subsequence of an will be convergent to the same limit L. Okay, let's understand with the help of an example. Now, yesterday we have done an example that was an is equal to 1 by n, which was converging to 0 as n tends to the infinity, right? So let's say if you see the terms of this 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, and so on. So if you take only even terms, let's say 1 by 2n, or you take only odd terms, let's say 1 by 2n plus 1, or you take only 5n's, let's say 1 by 5n. So in all these cases, if you take n tends to the infinity, all these subsequences will go to what? 0?
Same limit.
Same
Right?
limiting value.
Right? So they have same limiting value, right?
Yes, sir.
So in other words, or let me draw a picture for you. So if you have something like this and you have 0 over here, okay, and you have say 1 over here, and this is your half, and this is your say 1 by 3, and then 1 by 4, and then 1 by 5, and then 1 by 6, 1 by 7. Now you see that that pattern is not going to change. So if you discard few terms from it, let's say you discarded 1, 1 by 3, 1 by 5, and you are picking only those terms, 1 by 2, 1 by 4, 1 by 6. Still, the cluster is, the terms are going towards what? 0.
0.
So the cluster
0.
will not change, right? So if you discard a subsequence from it, the remaining subsequence will also be convergent. Okay,
Yes.
right? So
Yes.
mark my words, what I've told is, that is every. This is an important word, right? कोई भी subsequence उठाओ अगर convergent है तो वो subsequent भी उसी same limit को converge करेगी. Okay, so now there is second note. That's what, if a sequence, ठीक है, if a sequence is divergent, right, then two cases may happen, right? One, then either one of its subsequence, either one of its subsequence is divergent, or any two subsequences converge to two different limits. Two different limits. Now let's understand why it is happening. So I'll take this case first. I'll show that if a sequence is divergent, then one of its subsequence has to be divergent. Okay, so I'll take this first case, right? So let's say let's do an example. So we have an to be, say, n. So if you take 1, 2, 3, 4, 5, 6, and so on, you know that where an goes to infinity as n tends to infinity. So we pick any subsequence of it. In fact, any subsequence of it is divergent. But if you pick, say, a2n, right, you pick only even numbers. Even then, if you take n tends to infinity, your a2n will tend to what? Infinity. Right? But this is true when when your subsequence is divergent. But you may have a kind of oscillatory subsequence. Let's say what? If you have a sequence which we have done, -1 raised to power 1, right? So that was what? -1, 1, -1, 1, -1, 1, and so on. Ultimately, you know that your odd subsequence is -1, -1, -1, and so on. Constant है ना ये? हमेशा -1 नहीं आएगा इसमें. And if you take the even positions only, you will get 1. So this sequence will converge to -1, and this sequence is convergent to 1. So that means there are two subsequences which are actually converging to two different limits. That's why it has to be divergent, right?
Yes.
So
Yes.
this is our second case when we say that if any two subsequence converge to different limit, then the original sequence has to be divergent. And we know that this original sequence is divergent. Is it fine?
अगर कोई सीक्वेंस कांस्टेंट रहता है तो उसको कन्वर्जेंट.
ऑफ कोर्स वो कन्वर्जेंट ही है. उसका मतलब क्या होगा? अगर ग्राफिकली सोचो, 1 है, यहीं पे ही सारा क्लस्टर बन गया बस. कांस्टेंट हमेशा कन्वर्जेंट. ठीक है? Is it fine? So you got the idea of subsequences?
Yes, sir.
So why they are so much interested? That's what we have seen. Okay. So now we'll be discussing one more feature, one more type of sequences. That is what? non-increasing sequences. Right? Non-increasing sequences. A sequence AN is said to be non-increasing, right? If AN is greater than equal to AN plus 1. If AN is greater than equal to AN plus 1. Let's say, example, AN, take AN to be 1 by N. Now, if you take the terms 1 by 2, 1 by 3, let me put it in straightforward way. 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. So this is your A1, this is your A2, this is your A3, this is your A4, this is your A5. Now, if you check that, ठीक है, this A1 जो है वो बड़ी है A2 से,
Yes, sir.
Yes, sir.
A2 जो है वो बड़ी है A3 से,
Yes, sir.
Yes, sir.
A3 जो है वो बड़ी है
A4 से।
बराबर हो सकती है, ठीक है। अब मैं नॉन इंक्रीजिंग क्यों बोल रहा हूँ, डिक्रीजिंग नहीं बोल रहा हूँ, क्यों, बराबर भी हो सकती है इस वजह से, राइट। तो इस तरह से हम चलेंगे। और इसी तरह से नॉन डिक्रीजिंग कैसे बोलेंगे, जस्ट इसका उल्टा रिलेशनशिप, ठीक है। सो वी से दैट नॉन इंक्रीजिंग, सॉरी नॉन डिक्रीजिंग, तो क्या बोलेंगे नॉन डिक्रीजिंग के लिए, बोलो जरा।
AN is less than equal to N plus 1.
AN should be less than equal to N plus 1. But I didn't tell you for how many N's, for all N's or for some N's. What do you think?
For all, I think.
For all.
No, it doesn't matter. So let me give you a very beautiful result over here, and that's what which I want to discuss is we care mostly about tails of the sequence. ठीक है, तो मैं ऐसा बोलूंगा, इसी डेफिनेशन में मैं ऐसा बोलूंगा, ओके, सो let me select this first. Right. Yes. So I would say that for all n greater than equal to n, means after a cutoff, what I want to say is, देखो, so let's take an example where my sequence is 1, 2, 3, 4, 5, and then 1, 1 by 2, 1 by 3, 1 by 4, and 1 by 5, 1 by 6, 1 by 7, 1 by 8, and so on up to infinity. Now, can you see that the sequences are increasing or decreasing or non-increasing or non-decreasing?
First increasing, then decreasing.
Bolo?
It's first increasing and then decreasing.
Yes.
First increasing and then
Yes, but
Increasing.
you know that increasing decreasing part is largely connected towards the convergence of the sequences, right? We are doing this just to establish few more results towards the convergence, but right now we are not doing. We are just understanding the definition of non-increasing and non-decreasing sequences. ठीक है? So what I want to say is कि ये 5 टर्म कोई फर्क नहीं डालती हैं, ठीक है? जो टेल है, जो इनफाइनाइट टेल है, उसका बिहेवियर देखना ज्यादा जरूरी है।
So तो जीरो की तरफ जा रहा है कि इन्फिनिटी की तरफ जा रहा है?
हाँ, now this is your point. So okay, I guess you are capable enough to give the answer of this question. Let me tell you how. So let us plot it graphically, right? So that's what. So here you have 0, here you have 1, 2, 3, 4, and let me make it to 5 as well. Okay, and let this be 5. Now your first term is what?
1.
1,
Then 2,
2,
then 3,
3,
then 4, then
4,
5,
4,
5.
then 1,
Yes, sir.
then again 1, right?
Yes, sir.
Then we start like 1, and then we have what?
1 by 2,
Half, and
1 by
then
3,
1
1
by
by 3, 1 by 4.
1 by 3, 1 by 4, 1 by 5. Now what do you think? Is this a convergent sequence or divergent?
convergent,
Exactly. Why? Because we know
Because
that
converging
if
with 0.
इस cluster के बाहर finitely many terms छूट भी जाएं, we don't care about that.
Yes, sir.
Right? So if your finitely many terms are not behaving in a nice way, then you don't need to bother at all. Okay? So I would say that, more precisely, I would say that this is also a non-increasing sequence, but after what? But after n greater than equal to
5.
right? So if finitely many terms are misbehaving, they just consider them as bad fishes. You can easily discard them.
Yes, sir.
Okay,
Yes, sir.
but only for finitely many, not infinitely many, right? So these 5 terms are bad fishes. So you should always say that the proper definition would be like non-decreasing sequence for all n greater than equal to some m,
M.
and that m has to be finite, right? And
Yes.
because from the beginning we have seen that if some or if finitely many terms are not behaving, then it's fine, because we are only here to find the clusters, right? And cluster is the idea where, where the interval is containing the infinite numbers from the sequence, right? Even in the last lecture, if you say that, when I mentioned over here that only finitely many terms are living, right?
Yes.
Right? It actually, if you write it another way, if you read it another way, it only means that the tail has to be convergent, right? And if there are some finitely many terms which are not behaving, how many? M से पहले वाले. How many? Before M, right? So before M is what? This is the head of the sequence. And if head of the sequence is not satisfying this particular property, this inequality, then it's fine, right? Here 10 terms are violating this inequality. Is it okay?
Yes, sir.
Yes.
So that means what? We don't care about head. We only care about those infinite terms which are actually coming, which are actually appearing after n is greater than equal to 11.
11.
Right?
Yes,
So
sir.
Yes, sir.
even in a increasing or a decreasing sequence, you should consider the same idea. You should start with the same idea that if head is bad, then you can easily skip that. Fair enough?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now I'm putting one more thing into that. That is, we call it as bounded above and bounded below sequences, and in other words, bounded sequences. Okay. So let's understand in a very simple way. Okay. So we say that again. A sequence AN is said to be bounded above if there exists a real number m belongs to the real such that your an is less than n for all n belongs to the natural. बाउंडेड का मतलब क्या हुआ? बाउंडेड का मतलब हुआ बंधा हुआ होना, ऊपर से बंधा हुआ होना. ठीक है, जैसे let's take another example. Let's take the example of 1 by n again.
Sir,
Yes.
sir, where n belong to W लिखा हुआ है वहाँ.
नहीं, नेचुरल नंबर्स. अरे
अच्छा.
तुम लोगों का ना वो दिक्कत है, n नेचुरल नंबर सिंपल ऐसे n से नहीं लिखते हैं, साथ में एक लाइन लगाते हैं, राइट? दिस इज अ काइंड ऑफ स्पेशल सेट. ओके, इज इट फाइन नाउ?
Yes, sir.
Okay, so see 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. So is this a bounded sequence? Can you see that? Is it a bounded above sequence?
No.
क्या इस सीक्वेंस की सारी टर्म्स किसी एक स्पेशल नंबर से छोटी हैं?
Yes, sir.
Yes, sir.
Yes, sir.
Less than 1.
लेस देन
Yes, sir.
Equal to 1.
लेस देन इक्वल टू 1 है ना. इसके बारे में अगर बात करें तो ये लेस देन इक्वल टू क्या है?
1.
अच्छा, अगर मैं इसको लेस देन 2 बोलता तो क्या नहीं चलता? ये
चलता.
Yes, sir. चलता है.
टू विल वर्क और नॉट?
No sir.
Yes, sir.
ऐसे बाउंडेड नहीं रहेगा सर.
नहीं सर, फिर वो एक स्पेशल नंबर पे 1 ही हुआ ना, जैसे सबसे ज्यादा क्लोज है.
सर वो जो मैक्सिमम क्लोज लेवल पे हुई.
But I didn't talk about the closeness, right?
It shall work.
सर वो
है ना? So
1
it
के
will
पास
work.
Sir, it will work
It
excluding
will
the head.
definitely work, right? So
Yes, sir.
ये कभी कभी confusion होती है, so I want to remove that confusion. So I'll say that once a sequence is bounded above by a number, then there exists infinitely many bounds. Okay?
Yes, sir.
भाई एक
Yes,
बार
sir.
बंदा हो गया तो ऊपर से बंदा ही बंदा है ना. हमें तो उससे नीचे, हमें उससे छोटे चाहिए. तो एक बार अगर मान लो तुम्हें नंबर मिल गया, यू से 1, राइट? तो 1 से बड़े सारे नंबर इसके लिए बाउंडेड अबव का काम कर जाएंगे, इसके लिए बाउंड का काम कर जाएंगे. 1.5, 1.56, √2, कुछ भी, राइट?
Yes, sir.
You need to read the condition only. So the only condition is what over here? That we want to find one such m which actually satisfy this inequality, that all the numbers of this from the sequence should be less than n or less than equal to n, actually more precise.
Yes, sir.
Right? So it should be less than equal to 1. That's it. So if you put m is equal to 2, 3, 4, 5, all these all number which are greater than 1 will also satisfy this inequality, right?
Yes,
And
sir.
once the sequence is bounded above, it is bounded above by many numbers. True.
Yes, sir.
True, right? So हाँ बोलो. Yes. बोलो, anyone? ठीक है, चले आगे.
Yes, sir.
Okay. So let me put it in another way. Bounded below. तो bounded below के लिए क्या definition हो जाएगी? A sequence n is said to be bounded below if there exists small m belongs to R. I would say that small m हम use करते रहते हैं. Actually यहाँ भी हम ना sequence की definition में use कर लेते हैं. तो instead of m I will use capital K. Okay? Just to differentiate between the notations. That's why. So I'll say small k over here. If there exists small k such that an पहले क्या लिखा था, लेस देन इक्वल टू के, अब क्या लिखेंगे, ग्रेटर देन इक्वल टू स्मॉल के, राइट। सो क्या उसी को देखें 1 by n को, राइट। सो टर्म्स आर 1, 1 by 2, 1 by 3, 1 by 4. Is it bounded below?
Yes, sir.
Yes, sir.
किससे?
0.
0 और कोई? Of course.
Negative
Minus
sign.
1,
-1,
minus 2.
-1 by 2, कुछ भी, है ना?
Yes,
So
sir.
I would say the same note. Right. So I would put the same note over here, that once a sequence is bounded below by a number, then there exists infinitely many bounds, lower bounds. ठीक है, इसको lower bound बोलेंगे, ठीक है। यहाँ पे बोल देंगे there exists infinitely
Upper
many upper bounds. Is it fine?
Yes, sir.
Right? तो अब जो अगली कहानी है ना, वो थोड़ी सी इंटरेस्टिंग है, लेकिन अब हमारे पास उतना टाइम नहीं बचा है, वो हम कल ही कंटिन्यू करेंगे वो वाली चीज को। तो लेकिन आई वुड से दैट अगले हमारा ये शुरू होगा लीस्ट अपर बाउंड, सर, ग्रेटेस्ट लोअर बाउंड। बोलो बोलो बोलो
सर। ऐसे तो हर एक सीक्वेंस बाउंडेड होगी?
नहीं, जरूरी नहीं है। अच्छा, ये अच्छा कहा, चलो ये छोटा सा काम तो कर ही सकते हैं हम इतने टाइम में, ठीक है। सो लेट्स से नोट every sequence is not bounded. For example, n square is not bounded above. है क्या? कोई बांध सकता है ऊपर से इसे?
No, sir.
क्यों? Because it will keep on increasing, right? Unbounded का मतलब क्या है?
बाउंडेड बिलो तो है ना, पर
हाँ बिलो है, नो डाउट। मैंने अबव ही लिखा भाई, ध्यान से देखो।
बाउंडेड तो है इक्वेशन, सर मतलब बाउंडेड तो होगी।
बाउंडेड तभी कहा जाएगा अगर बिलो भी हो और अबव भी हो।
ओके,
ठीक है, ये भी ये नोट कर लो जरा। ए सीक्वेंस इज said to be bounded if it is bounded above as well as bounded below. हाँ भाई, ठीक है।
यस सर।
Excuse me, sir.
Yes, sir.
तो ये बाउंडेड अबव नहीं है, क्यों? अब देखो बाउंडेड अबव का मतलब क्या है। यू सिंपली इमेजिन दैट कि किसी चीज को ऊपर से बांधा हुआ, राइट, उसको क्रॉस नहीं कर सकती वो। बट हियर इफ यू पुट एनी चैलेंज टुवर्ड्स इट, इट विल क्रॉस इट। You say that you ask the sequence that can you be bigger than 100? It will say yes. After 11, I'll be bigger than 100. You put 11, है ना? समझ में आ रही बात?
Yes, sir.
Can you be bigger than 10,000? It will say yes. You put 101, I'll be bigger than 10,000. Is it okay?
Yes, sir.
Okay, so these are the things. So tomorrow we'll be discussing the least upper bound and the greatest lower bound.